Hey, I'll just want to keep you right on track. So if you're going to be out on Tuesday, this would be the good video to watch. So this will be the PowerPoint that we're going to be using. The first half of class, we're going to kind of go through the different types of graphs that we learned last Friday, and you had the lesson on, just kind of reviewing everything and then doing more practice with it. And then we're going to continue on to this. And so these last two lessons will be about um, so this lesson's about going from a complex number, so stuff that's imaginary, and putting it into trig form. And then we're going to go back and forth. So there'll be some key things for you to know from this, but it's a pretty simple lesson. So the beginning of this lesson is just kind of reviewing some of those ideas that you learned in Algebra 2 or even in Algebra 1 about complex numbers. So that's the do now. If you haven't given yourself a moment, hit pause, try to do those problems, and then come here and hit unpause. So the first one, number one, there is to simplify. So you can think of distributing and combining your like terms. You should have gotten -1 plus 7i. For number two, we want to write the following in standard form. So standard form is a plus bi. So even though we're going to go ahead and multiply by the conjugate here so that we can get rid of the denominator having that I there, what you're then going to want to do is after you multiply everything through, separate it so the form, like I said, a plus bi. So this, when you end up in the numerator, you would end up with 3 plus I over 5. But so then if we're going to write it in the standard form, we would then separate it into their own fractions. For number 3, we're essentially foiling everything out. So when you FOIL, the plus 6i and minus 6i should cancel out. And then the 2i squared becomes a minus, or the 4i squared, sorry, becomes a minus 4. So essentially you have -9 minus 4, giving you -13. And then for number 4, we went ahead and graphed it. So keep in mind that this is your real number system. That's the x-axis here. And then you have your complex numbers is the y-axis there. So if we were to graph 1 plus 3i, we'd go over 1 on the real numbers and then up 3i on the other one. Okay, I realize this is over at 2 plus 3i, so it should actually be over here. At this time, I can't get this to edit right now, so just know it should be over 1. So just continuing, we're just going to go ahead and sketch these. So if I have a -2i, that means I'm going to go on the complex number system here and go down a length of 2. If I have z is equal to 3, that means I'm going to be on the real number line at 3. So then 1 minus 3i is found here. And then 2 plus 2 squared of 3i, that 2 squared of 3 is a little more than 3. I believe it's like 3 point something, 3.7, I believe is what or 3.8, something like that. Okay, so that's the idea. All right, so let's get into the new stuff. What we want to do is if I give you something in standard form, we're going to convert it to rectangular form. So for example, what we have here is the standard form, which is z plus z equals a plus bi. So again, that's your standard form of a complex number. So then if I want to know what the distance is of this complex number, it's essentially the distance from the origin. So we're kind of think of it like magnitude almost. Okay, so if we have ourselves the real number line is going this way, we have I, this is our imaginary system, and there's a length z here. So essentially we're going over A, up B, and then this would be the distance z, which we normally call as r. So if we want to find that, that should be a 2, not an s, but again, I can't edit this right now. So we have a squared plus b squared, and then we're going to take the square root of it, and that would give you what this length is here. Again, that's nothing new to us. So here's the new thing. So what the trig form is written like this, where it would be r, then in parentheses would be cosine theta plus I sine theta. And in a moment, I'm going to explain to you where that comes from. So in the second example, I'll explain to you where this formula is coming from. But anyways, so if I want to, I'm going to essentially take the problems that are in this form, a plus bi, and we're going to convert it into our trig form. Now, because it's always going to be this cosine theta plus I sine theta, we do have an abbreviation for that. And what we really do is kind of take the values in front, so the C, the I, and the S, the main pieces of that, and we actually put it together to form CIS. So this is CIS theta. That's just abbreviating this here because, you know, as mathematicians, we're a little lazy. So this is what we're going to be using over this lesson and our next lesson. So let's do an example. So I have z plus 2i squared of 3. That's in standard form. So what we're going to do is find its the magnitude there, or the distance from the origin, how far that away is. So we're going to be using our excuse me, distance formula, essentially, or Pythagorean theorem. And what we end up with is r equals to 4, because 2 squared is 4, 2 squared of 3 is 12. When we square it, add them together, it's 16. Square root of 16 is 4. So the r value is 4, r times the CI. So the next part of this is to then use this information to find out what theta is. Theta here, since we're talking about 2 plus 2i squared root of 3, we know z is going to be found here. We can be in different quadrants, so we're going to try to find that, and that's when we're going to be using tan inverse. Now you could do cosine inverse or sine inverse at this point. Doesn't really matter. I chose to do sine or tan inverse. If we're in quadrant, remember quadrant 2 here, we probably would want to do cosine. If we're going to do this one down here, we want to do sine or tangent. So if we set it up, a theta is opposite over adjacent. This simplifies down to square root of 3, and tan inverse of square root of 3 is pi over 3. So we're going to put in this form. We found r in the beginning here. Now we know what theta is. It's pi over 3. So to rewrite it in trig form would be like this. Okay, so that is going from standard form into our trig form, into complex into trig form, standard form into trig form. So the other example of this is going the opposite direction. So what I wanted to do is go over with you where the r cosine theta and the r sine theta is coming from and so on. So if we have any random triangle, AB, because this is length B, because this is BI, and we have you can think of it like your radius if you'd like. Cosine theta would be adjacent over hypotenuse. Sine of theta would be opposite over hypotenuse, giving the result of these two fractions here. So then from there, I can solve for A. So A can be represented by r cosine theta, and B can be represented by sine theta. Fairly similar to the stuff we were doing with our polar coordinates, where we're saying, okay, X was r cosine theta, and B was r sine theta. But we're not working with X and Y, we're working with A and B because that's the standard form for a complex number. So if I know that A is r cosine theta and B is r sine theta, and I know that Z is A plus BI, what we can do is replace A with so if I replace A with r cosine theta and B with r sine of theta, I end up with this. Well, both of them have r in it, so we can factor the r out, and that's where the r times cosine theta plus I sine theta comes from. And then from there, we can abbreviate using the CIS theta. Okay, so let's go ahead and do an example where now I'm going to be working with something. I'm giving it to you in trig form, and now we're going to be putting it into the complex numbers standard form, which is A plus BI. So we're going to go the opposite direction. So here's the example with that. I have square root of 8 CIS of the negative pi over 3. So the first thing you're going to want to do is expand it, working our way backwards. Keep in mind that this is in quadrant 4, where the negative pi over 3 is in quadrant 4. And that's important when you're identifying A and B to make sure that you're in the right quadrant. So we're just going to expand it with the idea of what the CIS stands for. So remember, the C is cosine, and then we have our I, and then we have our sine. And this is the same exact theta for both of them. So then the next step here would be to evaluate. So cosine of negative pi over 3 is 1/2. Sine of negative pi over 3 is negative square root of 3 over 2. And we know that the square root of 8 can be simplified to 2 square root of 2. And then from there, you're just distributing through and simplifying. So when you distribute through, we end up with square root of 2 minus I square root of 6, which is found in quadrant 4, so we know we're in the right place there. But that's the idea behind it. Okay, so those are the two things that we're going to be working with today. After this, the students are then going to do a partner activity. Since you probably don't have a partner to work with, you can work by yourself, and doing practice converting back and forth from complex to standard and standard into complex form. So that's what the directions are here. This is the homework that is assigned for this evening. So page 562 to 63, numbers 17, 21, 33 to 36, and so on. I do have polar graphs for you to use, so if you stop by on Wednesday, you can get the polar graphs for you to use there. Okay? Otherwise, I hope you had an awesome time on your science Olympiad. Hope everything went well with that. I'll have a voted video for those of you who are also going to be on the robotics trip on Thursday. So, sorry, that was my daughter's cell phone. So if you have any questions, just shoot me a message. Otherwise, this is it. All right, have a great day.